Nice to be here. You can tell I'm kind of an old guy. I've got talking heads on my starting screen, but what I wanted to do was talk about sort of how did we get to the point we're at. I think HTAP is, I'm excited to talk about it. It's one of the things that I've been really interested in for a long time, and got an opportunity to show up here, and this seems like the perfect place to talk about that. So hopefully you guys will learn something, and I'll learn something if you guys ask me some questions and enlighten me on stuff. So first part's the introduction. I'll give you a little background on myself real quick. I'm a longtime database guy, so I started with the very first version of Oracle, believe it or not, back in the dark ages. Version 2, Larry didn't want to have a version 1 because he said nobody would buy version 1, so the first commercial version was version 2. I have worked at a number of companies. I've published some stuff and done a lot of traveling around and talking to people about database technology. But just to give you an idea of why I'm interested in HTAP, this list of companies, the first one was I guess I'm a three-time offender when you think about entrepreneurial stuff, because I've been a founder in 3 different companies. The first one was the biggest one and had the least satisfying exit, but the second one was a company called Incotech that really focused on Oracle performance as a major part of what we worked on, which drug us into the combination of analytic workloads with transactional workloads. And that company ended up joining Accenture, so we did a little bit of time at Accenture, which was painful, but also a great learning experience. And then we spun off a company called Gluent, which really was focused on building a connector between a transactional database and an analytic database, actually a lot of analytic databases. So the transactional piece was a very small kernel of Oracle, and we actually built an architecture that looked like Oracle architecture. So if you guys are familiar with Oracle, it has a whole bunch of background processes that all access central kernel memory. And so our software also did the same thing. We had some background processes that directly accessed Oracle's kernel memory, and we let Oracle do the transactional piece, but we, under the covers, moved most of the data to some analytic engine like BigQuery, for example. And so in real time, when transactions would come in, Oracle would process the transactions, but anytime an analytic query was run, we would insert ourselves under the execution plan level. So Oracle would do the optimization, and then we would figure out what to do with that and go to some other engine and go get the row set that we needed to bring back in to answer that query. Okay, so think real-time translation specifically to do analytic queries in conjunction with a small transactional Oracle database. So that was Gluent. Gluent got acquired by Google about 1.5 years ago, so now I'm at Google and still very interested in this same space. Gluent doesn't exist as a product anymore. Now we're trying to figure out how to infuse all those ideas and that IP into other things in Google. So anyway, that's the background. That's why I'm here. And hopefully I have something to offer, in respect to what we ought to be doing. So quick outline, I won't read all that, but basically I'm going to run through some things. Part of it, the main part of it, will be a sort of a walk through time of how we got here, right? What did we do and how did we end up in the space we are in now? Okay, so setup. What do I think of when I think of HTAP? My P wrapped around on me, but you guys know the standard definition, right? Hybrid between transactional and analytics. And there's all kinds of crazy terms people are using now, augmented transactions and transanalytic, et cetera. But for me, it's a database, right? I don't think of anything except I've got a database that has to handle mixed workloads, right? Meaning I've got to be able to handle latency sensitive and throughput sensitive queries, right? And it also means that hybrid is really important because I've got to be able to do both of those, and I've got to be able to do them seamlessly, and I've got to do them in a performant way. So when I say HTAP, that's what I mean. Okay. So to dig a little deeper, what characteristics do I look for? Number one, it's got to be able to handle transactions, right? That's requirement number one for a reason, because that's what we've got to do as our number one goal, right? We can't not handle transactions in a performant manner. We've got to be able to handle OLTP workloads. We have to be able to provide low latency, low contention, strong consistency, all the things you would expect from a normal OLTP sort of database or transactional database. And the transactional piece, I do believe, is the most important part, right? It's the most important thing. And that implies, in my mind, that we have a row-oriented format, right? That's the way most of the transactional databases are built, and there's a reason for that, right? It's better at that kind of workload. By the way, feel free to interrupt me and ask questions if anybody wants to. I get tired of listening to myself. I have a low, monotonous voice, and I tend to fall asleep. So please interrupt me. Okay, so requirement number two, we've got to be able to handle the analytic stuff. What does that mean? We've got to handle high throughput, right? So I/O capacity has got to be substantial. Typically, we're doing full scans, so we're doing large multi-block reads at the hardware level, and those blocks are typically much larger than the blocks we use in transactional systems. So we also have a mismatch there, right? And this also implies column format. Column format is much, much better at analytic queries where we're doing full scans. We don't have to read the whole table. We read the columns that are of interest, et cetera, right? So there's a lot of advantages to a column format there. So now we've already got now two things that are problematic when we're combining these workloads. And the third one is that we've got to be able to juggle, right? We have to be able to go back and forth between those things seamlessly. And to be more specific, we have to isolate the single block reads or the small reads that the transactional stuff is doing, because typically we're reading an index, we're getting a single block with a single record in it, and we have to be able to make sure that that comes back in milliseconds or microseconds. So I can't afford to have my single block reads stacked up behind a whole slew of large multi-block reads just waiting for its turn in the I/O system. Make sense? Okay. My clown. All right, a couple of macro trends to keep in mind as we kind of go through this journey. Data volume's exploding. You guys know all this stuff. A lot of that's driven by IoT. We've got machines creating data, so instead of having, what we thought was a big database back in the day of a terabyte, now we've got petabytes, and beyond, right, in single databases, and that's not uncommon. We see that all the time. I'll tell you a quick story about a terabyte database. I once got to meet Bill Gates, which is kind of odd for a guy that's worked in the Oracle space all of his life, but at some point Bill wanted to break into the really enterprise kind of database space, and so he invited a bunch of Oracle people to come out and have a meeting with him to talk about databases, and Oracle had just announced that they had a terabyte database. This is the first time anybody had ever done it, at least that's what Larry said. So we get out there, and Bill comes in to meet us, a small group, maybe 30 people or something. And he says, I've been looking all over the world for a terabyte database. I can't find one. I've looked everywhere. He said, eventually I found one guy that said he had a terabyte. And it was just after the Soviet Union had broke up. And he said, it's a Russian guy that used to run part of the space program. And so he had a database of satellite images from around the world, from all their spy satellites, basically. And he was a former KGB guy. He's telling the story. And he's like, so I asked him, I said, hey man, it's good to meet you. Have you ever been in the States before? And he said, the guy looked across at me and he said, officially, yes. So anyway, he said, but he did have a terabyte database. And so anyway, he was trying to convince us that, SQL Server was going to be able to handle these large databases just like Oracle did. So anyway, I thought that was kind of interesting. But today, a terabyte is just, seems for the big enterprise database, it seems pretty small, right? It's pretty tiny. We're dealing with hundreds of terabyte databases all the time, and petabytes in many cases. So anyway, that's just one of the big trends. You guys have probably read all the rest of them by now, so I'll skip on. All right, so here comes the history lesson real quick. I tried to do a little timeline last night, starting with Ted and Chris's paper back in 70 or so, and going all the way through, where I think we're going to end up in the future. So we'll just skip through these real quick. Phase 0, Grace Hopper, Ted and Chris writing their paper, IBM phase. I'm not going to talk about that at all. In the 70s, we suddenly got SQL databases based on Codd and Date's paper. And we almost immediately realized that we had this problem, that we couldn't run these kinds of queries. Number one, we had really slow machines. We had really bad disk I/O, and we couldn't run these queries, contemporaneously. We would have really bad problems with the transactions as soon as we ran a report. So we tried, time slicing. We run our batch jobs at night so that they didn't interfere with the transactions during the day. And we almost immediately started moving data from one database to another, right? So immediately the ETL phase, came about, the Informatica phase. And basically we are still partly in that phase, right? We still spend a lot of time moving data around from one place to the other. In fact, many large enterprises spend more time moving data than they do anything else with their data, any analyzing or anything, right? They're spending all their time on their batch jobs, moving all the data, transforming it to put it in a different engine. Why? Because we couldn't run the workloads, in the same engine. We had to split them some way, and this was the easiest way to split them, was just put them in two databases. Came with a lot of downsides. Replication of the data, so the cost goes way up. Even worse, we get data drift because, if we're moving data from one place to the other, it's very common that the data gets out of sync, right? It's not exactly the same. So anyway, lots of bad problems with the movement of data. Pretty soon thereafter, we started figuring out ways to have clustered databases or sharded databases. Not the same thing, but similar in concept in that we've got multiple machines accessing the same set of storage, the same database, right? And by the way, I should back up and say, what is a database actually? In the early days, super simple. The whole idea was, what can I cache so that I don't have to do I/O? Because I/O is the slowest part, right? So it was really basically trying to build a sophisticated cache that could move data into memory so that I could access it in a reasonable amount of time. So these clustered databases allow us to have multiple machines also caching the data, and it's the same set of data, so this came with some side benefits. The side benefit is that if I am caching data in different machines, I have different I/O systems on those machines, right? So I can also isolate the workload by saying, well, I'm going to send all my guys that are running reports to this node in the cluster, and I can keep all my transactional guys on this set of nodes in my cluster. So again, we're trying to figure out a way to split these things again. So this may not sound like it was really a big deal, but the clustering and the ability to have access to a shared database across nodes really did give us a lot of ability to have a, kind of an HTAP system, right, where I could run transactions and analytics on the same database. Okay, phase 4, the distributed phase. Not too long after this, a smart guy named Doug Cutting started thinking about how can I do really scale out my I/O and improve that I/O issue. And so the idea was, can I use a lot of small machines with direct attached disks? My disk I/O is not any faster, but the bottleneck by this point had become the interconnect between the SANs and the computer, right? Because now I've got a lot of disk I/O available, but getting it into the machine became the problem. So the idea is spread the disk out into a whole bunch of machines, initially hundreds, then thousands, of disconnected computers where we could push the work, and the key part is push the work to where that storage lived, right? So the whole idea with Hadoop was I've got a workload I'm going to run. I'm not going to run it in move all the data and run it in a centralized computer. I'm going to push the work to where the data lives. All right, so another great idea for improving this I/O system and also isolating that I/O potentially from transactional low latency, small read, I/O. Okay, so also a big advance. Phase 5 was the joining together of many of these technologies and ideas that had occurred over the previous 15 years or so, right? And so Exadata is a super good example of that. Whether you like Oracle or not, the idea of taking a column engine, which came about when we started splitting databases, but putting that into a relational database that's row-oriented. So that idea was one of the things that Oracle did. In Exadata, we did a lot of things like the distributed disk, right? They had a storage layer that they were able to push work to. So we had a bunch of disconnected disks, all capable of doing processing. Oracle split their processing so that when I did I/O, I could spread it out across lots of disks, just like in a Hadoop system. And I could also push the filtering and the aggregation stuff down to those disks so that I got a relatively small amount of data coming back up the pipe. So I eliminated that big bottleneck on the pipe getting back to the machines. So again, a great combination of a lot of different things that made that work well. One of the things that most people don't know about Exadata was they also built a I/O queuing mechanism that was set in front of the I/O queuing mechanism at the operating system level. So I did still have, with Exadata, some compute nodes that did the final mile of the processing and did the transactional stuff. And in those systems, instead of when I did an I/O immediately going to the I/O processing in the operating system, they actually would queue the I/Os separately themselves. So they had a separate queue for large I/Os and a separate queue for small I/Os. And that way they could prioritize that, and they would only let out a certain number of I/Os to the operating system at their determined point in time. So obviously the transactional stuff got prioritized, would get through the operating system very quickly. The long block reads, are throughput sensitive, not latency sensitive anyway. So it didn't matter if I got on a few microseconds sooner or later, right, where it did matter to the transactional stuff. So that was a brilliant move that they implemented in that system. The last phase I'm going to talk about is federation, which is the phase that we're kind of in now. There are good things and bad things about federation. The great thing about federation is that I can get access to data all over the place. The bad thing typically is that the performance sucks. So lots of problems with moving data sets again to some centralized resource and being able to perform well when you're doing that. So, the idea of a data mesh or a de novo or a truly federated system is good, and there are great things about it, but from a performance standpoint, it usually doesn't work that well for large data sets. Okay, I'm going to stop here and see if there's any questions or comments before I go any further. And I'm a very patient guy, so I can sit and wait. Yeah, so the question is, what's my view on non-textual data, so images, sounds, streaming data? So a couple of things. One, traditionally we've done much better with that not being in the database because, again, you've got large objects. As soon as you get blobs in a database, you start having all kinds of other issues. Again, everything becomes a large read. If you're trying to read that, and it also interferes with the row format, if you've got to have out-of-line storage for it, et cetera. So generally speaking, my opinion is it's probably better to have that in some bucket, or something, and point to it, with record locators or, pointers to the files where those things are actually stored. Other questions? Yeah. I'm gonna ask you to speak up a little bit. I'm an old rock and roll guy, and my hearing is not that great. Yeah. So the question is, what's the difference between in performance if you've got a truly integrated system, like say an Exadata, versus you're combining systems like I described. Well, I don't know if I described it or not, but Gluon I described a little bit, right? Gluon had an Oracle database combined with a BigQuery database or some other analytics. So pros and cons, right? The pros of the integrated system is I can control my networking, so I can use something like InfiniBand or some very high-speed network, and there, I can do things like, prioritizing IOs and things like that. Disadvantage is that, you're locked into a single vendor and you've only got, you can't do best of breed sort of thing. On the other hand, you do have some advantages because it's engineered to work together. So you've got, people that have worked on this stuff for a long time and done a good integration job. The good side on the open source side, or the, the more open approach of using different best of breed products, is that you have a lot of options, right? You can say, I'm tired of Google and I'm not going to work on BigQuery anymore. I'm going to move that to Snowflake. Snowflake can run on multiple clouds, so maybe that's a better option for me. Maybe the technology is better for certain things that I'm doing, or they have features that's better. So you do have a lot of flexibility. And in general, one of the things about the integrated systems is generally they're located in one place. So you don't have the additional concern of how much latency you've got between locations of where things are. So for example, if something's in the cloud and you've got an on-prem machine, now you've got the latency of the internet connection to deal with as well, even if you've got a dedicated interconnect or whatever. But so you can eliminate that piece with an integrated system as well. So that's kind of a rambling answer, but in general, I think it's flexibility versus what you could really squeeze out of an integrated system. Anything else? Yeah, in the back.
Thank you. Good timing. So, talking about the future, could these large language models or trained models be in the new future of, like a database instead of traditional databases? Do you see something like that?
Yeah, I work at Google, right? So everything is AI today. It's like, and in the whole market, right? Everybody's going kind of crazy on the AI stuff. I have mixed views on it. There are things that it's going to totally change our life, right? We're not going to be, I don't think we'll be doing much writing. I think, documentation and all kinds of things where we have are writing stuff down, I think is going to be very easy for us to do compared to what it is now. When you sit and stare at a blank page, if you're a writer, it's super hard to get that first sentence out, to get started on what you're going to do. Once you've got something on the page, super easy to edit, right? Or if somebody else takes a start at it, super easy to edit. And so if nothing else, just prompting us as to, you've already written all this code, I can automatically document that. It may not be to your liking, but it's going to be a lot easier for you to edit that than it is to, go from top to bottom and try to figure out how to start. But one of the things that we're doing at Google is trying to write code. So we're trying to write code that translates. For, one of the things our team works on is SQL translation. So if I'm going from an Oracle database or a SQL Server database to a Postgres database, right, the SQL dialect is quite different, and particularly the procedural part of that, right? And so we've spent a lot of time writing code that translates code, and it's very deterministic, using a syntax tree, model to do that with. When we get into the AI space, also there's a lot of promise to that, right? A large language model can say, I see this thing, I see some examples of how to translate that. I can go look for that pattern, And I can apply, even if it's just single shot learning to those use cases and, come up with something. The problem is the hallucinations, right? We have AI at this point is really great at answering fuzzy questions, right? So if you ask me how to get to the Safeway over there, I could give you 4 different routes and they could all be valid, right? If I'm trying to write code, it's very precise, right? And so I have a much more difficult time of being that precise with AI at this point. And so what we end up with is, again, we've got an outline, but we're going to have to go and manually say, is this actually going to compile as a first test? If it compiles, is it going to perform as a second test? Right, so our job shifts somewhat from writing code to supervising code, that gets written. Eventually, I think we'll hit a tipping point, and that may be a lot sooner than we think. It may be this year, where the AI models actually can do that accurately. But today, I'd say we're not quite there. So, okay, I'll hit the future real quick before we're completely out of time. Most of this stuff won't be probably too much of a surprise to you, but when I'm talking to people inside Google about where I think we should be heading, I think that I should be able to have an application that connects to a database. I don't think it should have to care about where the data is located. The system should know where the data is located. If I've got data that's primarily used for analytics, it should be in an analytic engine, BigQuery, for example, and I should be able to issue a query with the one language of the database that I'm connecting to. Should be able to be translated on the fly to get the data I need out of whatever the other engine is. It's got to be able to push the work to where the data lives so that I've got a small lag to get the data back so that it's performant. Obviously, it's got to isolate the workload so that the transactional stuff can happen, in the speed that it needs to go. But in general, it needs to be a single interface. I need to be completely isolated from where the data is located, from what engine it's in, and that's it, right? So that's the gleam in my eye is where we think it ought to be, and it ought to be scalable. It ought to be able to run with petabytes and maybe exabytes at some point without any worry about how we're going to do that, which means it's got to be scalable. It's got to be serverless basically to be able to scale up and down as I need it, and that's sort of my view of the future of where HTAP is going to be. So. There may be more comments or questions about that than anything else. Yes, sir. We're talking about it. So again, part of the reason for Gluent joining Google was because we have this idea and have worked on that, and that product's been put on the shelf for the time being, but the IP is being developed. So, there is a strong interest in doing that, and I'm going to say it's not going to be in the next 12 months, but I'm going to say, in the next year, 2 years, 3 years, something like that probably will exist. So it's not very far out. It's always going to be incremental, right? We're going to take a first cut at it and improve it as we go. But
will what you are now developing be open source?
That's a great question. So Google is somebody said earlier, that PingCap punches above their weight in terms of open source contributions. Google punches under their weight in terms of open source contributions, just to be frank, right? So there's also a lot of discussion about how are we going to start contributing back. Part of this Gluent IP is going to be most likely contributed to open source. So several acquisitions that we've done recently, we're planning on taking that IP and putting it in open source. And we're actually building things now that are getting contributed. So it's part of what our team is working on, is trying to build some of that muscle inside Google as well. So it is an effort that's ongoing, but it's hard to say. The powers that be have to decide, is this something that we want to keep proprietary, or is this something that we're going to open source? But the trend is towards open source. What else? I don't know if we're probably out of time, but. Yeah. So the question is, do you see AI in the future developing more complicated data models and ones that probably human beings aren't able to put on an ER diagram and, deal with, right? And my answer is pretty similar to the answer I've already, stated, that yes, I think that there's going to be a tipping point some point in the future where the preciseness that's required for that sort of thing will be there. I think today we're probably still, a little too fuzzy on what we're doing with it. So, but yes, at some point, the most dangerous things we can do with AI is teach it to code, one of the most dangerous things. Because once we teach it to code, now it's going to start improving itself faster than we can keep up, probably. And so we're not to that point yet, but I think we are teaching it to code. We've already, taught it to manipulate human emotions and feelings and stuff, right? So yeah, we have some things to think about in that realm, right? And we also have to think about what do we enjoy doing and make sure we don't put ourselves out of the enjoyable jobs, right? Yeah. So anyway, it's a super exciting time, guys, and I'm super happy to be at Google because, the sky's the limit in terms of what we can do. It's really up to our imaginations of what we want to do, all of us, so not just inside Google, but the whole industry is at a turning point. And so, if you can imagine it, in the next handful of years, not like the 30-year history that I've had, watching things go a decade at a time, but now we're talking about very short time frames of making super advances. So it's a really exciting time to be, in the business, and I hope you guys are all excited about it.
When you say storing data in all sorts of engines and formats, are we also talking about, following up on his question only, that the same kind of data will be modeled as a graph and it will be also modeled in SQL, and then based on the application, we'll be able to leverage that particular type of database engine to get our results fast and accurate?
Yeah, what I really meant when I wrote that was that it could be in a row-oriented format, it could be in a column format, and I shouldn't have to worry about that, right? I also shouldn't have to worry about the syntax of the particular engine. I should be able to see, maybe the comment down at the bottom, there'll probably still be 50 dialects of SQL, in the future, even though we've all got flying cars by then. But we shouldn't have to worry about, going from one version or one dialect to another. We should be able to issue one query in whatever dialect we want, basically. And then that should be translated on the fly to whatever engine happens to be storing the data, right? So, and there are things like that out there. Gluent's, an example of something that's similar to that. But not that I'm aware of today, but keep your eyes peeled because there will be some stuff coming out of Google that will be open source. So. Could be one tomorrow. There's a lot of people working on a lot of stuff. So anyway, thank you for your attention. I'm here for a little while, so happy to hang around and talk.